Hello there, Kevin Culp back at you from Supermicro. So in the previous videos, we laid out our architectural design blueprint of how we're going to serve up NFS storage utilizing Supermicro's Sonic switch fabric. Today, we'll demonstrate through SCC's dashboard how easy it is to provision VLANs without having to access the CLI of both the 3748 Supermicro Sonic switch and an Arista switch. Our intent for this podcast is to inform the viewer of how Supermicro switches can interconnect with other third-party switches, understand how emerging technologies can be deployed, understand SCC's integration effort with third-party switches, and maybe, perhaps some viewers might have an unfamiliarity with rolling out a KVM hypervisor. Perhaps presenting an NFS storage repo to a KVM hypervisor, storing QCOW images in that repo, and general management of your VM guest instantiation. We'll also show you how to instantiate a VM guest through the KVM hypervisor. By no means is this the only blueprint you should follow for your enterprise. Importantly, working with storage administrators and network personnel are important recommendations you should consider before you deploy into production. Word of advice: plan in advance so there are no surprises. Too many times I have saw administrators fly by the seat of their pants. Ha ha ha, me included, and got burned. Takes a while to bring back your credibility when your entire infrastructure goes up in flames because of your silliness. In any event, let's jump into it. Okay, so we have the dashboard here that's been presented to you. Again, I previously mentioned in other videos, we have role-based access control where we basically have compliance and governance. We built in specifically users to be assigned roles. We call that role-based access control. We're going to show you, instead of using basically global admin, we're going to log into an Active Directory server or an ADM server. So we have this in our sandbox, an Active Directory server that's going to basically validate our credentials that are logging in. Our domain we're using is scc-demo.org, and we're going to log in. We've already set up an account over on that AD server, which is a Microsoft AD server, and we're just going to go ahead and, based on the group that is set up within the AD, because I have global admin privilege, I'm going to log into the platform using those credentials. So let's put in my password here. And immediately we should get directly into the dashboard itself through the credentials of logged into the AD. So when you log into SuperCloud Composer, based on that user account and that group that you're part of, you will only be presented with certain particular menus, options, and certain things that you can do within SuperCloud Composer. Again, we institute compliance and governance, so in an enterprise environment, these are very, very important to be able to provide our enterprise customers. So what do we do? What's the first thing we do? Well, we need to really present VLANs to our storage fabric. So remember, this is where we're storing those QCOW images, and so we're going to have to create an NFS mounted disk. So we'll have a volume here presented to our KVM hypervisor, and that will be utilizing our backend storage, which will be the NFS server. So we have this NFS client, which is basically our hypervisor, and we have the NFS storage server, which basically contains a mounted NVMe drive that we're actually going to present to the KVM hypervisor. And so NFS uses, it stands for Network File Share, utilizes TCP/IP as the transport to intercommunicate. So we've identified a storage server, which is our G3748 sonic switch, which is going to be that interconnection of the two systems that can communicate with each other and present that storage to the KVM hypervisor. So let's go into the network module itself. And what you'll see here is we have the Arista switch, which is going to be utilized as our connections into our KVM hypervisor. We're going to present multiple VLANs there, VLAN 100, VLAN 200, and VLAN 300 for one of the NIC connections. And then we'll have an LACP port channel from the SAN fabric of our G3648 sonic switch to two NIC that we have on the KVM hypervisor. So we're utilizing two NICs. They're actually load balancing for an LAC mode of 4 bond. So it's a Linux bond to bond 4 with our LACP. And then we're also doing that as well on the NFS storage server, right? So our client or KVM hypervisor has two NICs that participate in a bond, and that is an LACP bond. And then we also have that on our NFS storage server, which you'll show later, where we've set up the bond and we're using mode 4 over there. So the first thing we're going to do is focus on really presentation of our storage repo, so that our VMs can basically be stored in that actual storage server instead of relying on local disk of the KVM hypervisor. Could that be done? Absolutely, right? But as you scale out your environment, you want a large pool of large drives to be able to store your VMs so that when you spin them up, they'll be ready to be deployed within your enterprise environment. So the first thing we're going to do is we're going to click on basically what we call the sonic switch. So the sonic switch is a NOS operating system that's run on a Supermicro switch. It's a G3748. Typically a G3748 would be utilized for management purposes, but because of what we're doing here in our small lab setup to really demonstrate to you what can be utilized, we have very limited amount of hardware because we're shipping all the switches to many customers that are deploying in their enterprise. So we have a very limited amount of inventory that we can utilize here. So we're using basically in this case a 2 gig LACP. So two ports that have been identified on the sonic switch, both have 1 gig interfaces, will be LACP together. Is that something you would want to deploy in your production environment? Absolutely not. You want something maybe as 100 gig interfaces that maybe perhaps are LACP together for providing 200 gig, or maybe you have additional requirements for larger particular bandwidth ports that need to maybe occupy or be aggregated together. Instead of maybe using 2, you may use 4 to create 3 or even 4 members of the LACP port bond and have a number of NICs that you have set up on your NFS storage server. So by no means is this the entire blueprint you should use in your enterprise. It's just giving you a flavor of what we can do with integration and emerging technologies that exist out here. And really it's about an enterprise play here, right? So the first thing we're going to do is look at the physical ports. So we have 4 ports. We have 2 ports that are going to be connected to our NFS storage server, and 2 ports that are connected to our KVM hypervisor itself. And so what we're doing here is we're going out and basically providing what we call physical ports. We need to basically understand what VLANs have been presented. So I've done a little bit of work up front here so that at this point, we don't go ahead and these videos go on and on and on. We're going to try to save some time for you. So Then you can see how you create what we call the lag and present the appropriate VLANs themselves to the lag. So as this is turning in the background of bringing up all of our 48 ports itself, it's going to take some time to basically build that list or that element list. And then what we'll do is once those ports become available, we'll scroll down, show you those ports, and then begin our preparation of creating what we call a link aggregation group. Okay, so we have our list here, and so we're scrolling down to ports 43 and 44, and then also 45 and 47. So what's important here is to really understand your cable plant, right? One of the things you don't want to do is try to connect one particular port that's connected to your NFS storage server and say one port that's connected to your KVM hypervisor and try to create a port bond there. Obviously that's not going to work. That's not supported. It's basically a port bond that exists from two ports that are connected to an NFS storage server and two ports that are connected to the client, NFS client. So we're going to go ahead and click on 43 and 44. So I happen to understand what our cable plan is. So we're going to click on both of those at this point and come in and create what we call an Ethernet connection for both of those. So we're going to put those into what we call VLAN 720. But before we do this, let's go to the VLAN list and just make sure that VLAN 720 exists. So VLAN 720 is what I've identified is going to be a subnet, which is 192.168.5.x. That is a subnet I actually created, and we're going to define IP addresses on each one of those servers themselves. So we have VLAN 720 that's already created up front for you. And we're going to go now and actually determine if we have any lags set up for each one of those ports. So let's click on the logical port identification here, see if we have any lags set up. I've actually deleted them because I've done some testing here to make sure this works. I'm just showing you here how to navigate around the platform to look at different things, right? And you can see here that we have no lags that are basically set up. So these are logical aggregation groups or port groups where we group ports together to get that part of bandwidth to support our traffic that's associated with storage. So let's connect back into the physical aspect of the port itself, and let's choose to create a lag for ports 43 and 44. So we'll give a second here for this to go ahead and view. Now you'll see there's a little bit of lag time here in regards to our communication to the 3748 switch. In a previous video, we explained the fact is that we're working on allowing the NOST operating system to be more responsive to our API request into the web UI. The 400 gig switch seems to be a lot snappier. The 3748 has a bit of a challenges as far as response that we're communicating with it. So we're going to go ahead and again build up the element list to 100 entries. There's going to be somewhere 40 plus type of ports on here, so I've actually set it to 100 entries so that we can speed up this process a little bit. And we're going to scroll down eventually when this goes ahead and renders. and we're going to come down here to port 43 and 44 again, and once we do so, we're going to come up here and basically create what we call the lag. So you'll notice here that we have two indexes, 43 and 44, and we're going to call this guy port channel 1, and this we're going to call as NFS storage lag. Oops. And then we're going to submit here, and when we submit, it will essentially take a few minutes to basically build that LACP. It's going to communicate with the bond upstream to us and create that LACP port channel. I'll show you a little bit later how you can check the bond. And then also we'll see if it actually does create the bond. You'll see two actual ports that will now be members of that lag. And it should show that each of those port members are participating in that lag and show a state of up. And then once we create the lag, then of course then we have to present the appropriate VLAN to that lag. By default, native 1, which is VLAN 1, gets associated with any particular switch, but in our case, we're going to go ahead and create an access port for VLAN 720. That's part of that lag. Now, there are some folks that basically say, and it goes back and forth here, do we actually tag traffic associated with our storage, or do we untag, right? So my philosophy is that we go ahead and untag the traffic. Don't provide tag traffic or a tag VLAN, because you're just adding extra, what I'm trying to say here is extra payload to the packet, right? Where untagged is the packet now becomes less as far as the payload is concerned, doesn't have to deal with a lot of the VLAN tagging. So best practices is really set what we call an untagged type of VLAN. And of course, you need to look at the MTU size. You want to look at jumbo frames when you're communicating with your storage fabric. And then also make sure that when you do so, your MTU size is set correctly on the system as well that you're creating your bond, right? So if you're using an MTU size, it's of over 9,000, let's say like 9100, you want to make sure that your MTU size also is at the 9100 that you set on your lag and ports associated with your switch. And even if you're actually communicating, which I said in previous videos of communicating with interconnect switches themselves, you want to make sure that the jumbo size actually matches for both particular ports, even when you're creating a lag, right? So you don't want to have disparities between, say, running a 1500 MTU size and not using jumbo frames on one switch and maybe using jumbo frames on another switch, right? So they have to really agree or you get into a lot of trouble, right? As far as drop packets and all kinds of things happening within your environment. So let's scroll down here. And then the next thing we want to do is we want to create 45 and 47. So that is our another lag we're going to create. So we're going to scroll up here. Remember, we've created one on an NFS storage server. Now we want to create a lag on our hypervisor, where we're going to present that repo and those exported mounts. So we can say here KVM hypervisor. So we'll call it hypervisor storage itself. And we'll submit that. And at that point, go out and establish again that LACP connection to the KVM hypervisor itself. And once this comes back, we're then going to associate those access port VLANs, which is VLAN 720, to each one of the port channels. Once we do that, then at that point, we can go in and take a look at the hypervisor itself, see that the port bond has been created, and then from there, we'll move to actually the configuration of the VLANs on the Arista switch, where we're going to have our virtual machine traffic, our compute traffic intercommunicating. So we'll show you how you instantiate those VMs on the KVM hypervisor and then validate it through reachability of each of those VMs. We'll put them in different bridges. We'll get into all that discussion of how you set a .1Q trunk up on your KVM hypervisor, how you connect the vPorts with the vNICs, how you would instantiate a virtual machine, so on and so forth, right? So there will be subsequent videos that will follow here to show you the various different emerging technologies that we're bringing in to our lab to show you the value add that SuperCloud Composer brings from a lifecycle management perspective. So as this is turning here itself, let's go ahead and refresh here. And when we refresh, we should basically see the two logical ports that actually have been created here. So let's wait till this comes back with the logical creation of the two ports themselves. So if you needed to do this of presenting VLANs and you were doing this across multiple particular ports itself, it would take a lot of time, a lot of commands that you would have to initiate here. In the previous video, we showed you some of the network provisioning things. We'll touch on this a little bit again in this video just to give you a flavor of how you present those VLANs across multiple ports. If you look in the top right here, you can see here where we're actually now been connected in to our domain, right? We're using culp-k, so this is an account we set up on the Active Directory itself, and then we're connected into the demo.org, which is the Active Directory that we went ahead and created. So now you see here that port channels have been created successfully. So we have port member 42 and 43. We established that LACP connection. We're at 2 gig, but we're still in access VLAN mode, right? Which is 1. So if we were to basically initiate our mount request, we would fail. The mount request would fail because we're not in the right VLAN. So we partitioned our traffic for storage to be in VLAN 720. And so both of those are set up with the right MTU size, the right speed. We're showing operational state. So far so good, right? And so the next step here is to really go to these port channels and really come in here and set the VLAN setting, right? And so our VLAN setting that we're going to set for that is 720. So 720 is in the list. We're going to submit it. And so now we're telling that particular port, those 2 ports, present VLAN 720. So I can basically forward traffic of what we call storage traffic and between the KVM hypervisor and also the NFS storage repo server. So we have an NFS client that's running on the KVM hypervisor, and we have an NFS storage device or server that is actually presenting an NVMe drive where we're going to store those QCOW images. So we'll get this to continue to chew here. You can see here that we have a port VLAN failed. It's likely because of our MTU size itself, but we'll continue on with this deployment, showing you specifically what we have set up. You can see here that we have now VLAN 720 that's been presented to that port channel itself. And so now we're going to go ahead and present VLAN 720 to our other port channel itself. So 720 that we want to create, we'll submit it to the switch, allow the API to make some config changes to the switch on the port channel itself. So we've done this for the NFS storage server connection and also the NFS client being the KVM hypervisor. So give us a few minutes to basically make those configuration changes on the switch, on our Sonic switch. And at that point, we'll go ahead and what we'll see here is access VLAN 720. That shows up for both the NFS storage server and also the KVM hypervisor. So we'll see this value change from 1 to 720. And it has changed. And so now we have both, each of those ports have been identified for access VLAN 720. So this just concludes the provisioning of basically the storage. We'll see in the next video and show you how you can navigate through the KVM hypervisor and validate that the LACP port bound has been created. So we're seeing the operational state on the port channel. So we're in the next video, we'll show you how to get into the VM hypervisor and take a look at the port channel, show you how you would configure that as far as each of the Ethernet interfaces on it. So we'll see you next time. Thanks for joining.